First, looking at this expression, if we consider t to be small. Now, we'll see just how good this assumption might be, but we're going to assume that t is insignificant, so we're going to replace t by 0, so that the 4t squared is going to go away, and this entire part of the term is going to go away, as is everything but the 4 pi squared a squared on the k term. So the curvature is going to be approximately equal to the magnitude of the vector negative pi squared a. Let's go ahead and, now I'm not going to actually replace all the t's by 0. Let's go back a minute. I'll justify this, but we're going to leave the cosine of pi t and the sine of pi t in there because that's essentially what drives us around the circle. We're going to just assume that we're not going up very high as we go around this circle, so that the other terms are 0, but we're not going to assume that the pi t in here is completely insignificant. It's significant enough to drive us around the circle. Okay, now negative pi squared a times pi squared a squared is negative pi cubed. It's pi to the 4th, I'm sorry, times a cubed. And then that's going to be times the cosine of pi t times I plus the sine of pi t times j. So that's times cosine of pi t I plus sine of pi t j, and then we have our plus 4 pi squared a squared k. Now that whole absolute value is divided by this 4th power of the square root, which I'm going to write this time as pi squared a squared. I'm going to go ahead and write the 4t squared, although we're going to let the t go to 0 just so we don't lose complete track of where we are. Okay, and then the plus the 4t squared, but that's basically just a pi squared a squared squared. Okay, now what's the magnitude of this term? Well, that's going to be the sum of the squares of the components and the square root of the sum of the squares of the components. So on the I, we're going to have a pi to the 4th a cubed times the cosine squared of pi t. On the j, we're going to have a pi to the 4th a cubed times a sine, and that quantity is going to be squared. What we're going to then end up with is pi to the 8th a to the 6th under this square root, and the cosine squared and sine squared of pi t are going to ultimately add up to 1, and then we're going to have plus the square of this, which is 16 pi to the 4th a to the 4th, and that's all going to be divided by this. Now we're going to go ahead and let this t equal 0, and we're going to say, okay, that's pi squared, well, pi to the 4th a to the 4th. Now I'm not sure how much algebra I really want to impose on you, and on myself, I guess. The square root of pi to the 8th a to the 6th is just pi to the 4th a cubed. Dividing that by pi to the 4th a to the 4th, we end up with 1 over a. Of course, we still have this pesky 16 pi to the 4th a to the 4th over here. So what I'm going to do is I'm going to go ahead and divide through this term, or this expression, by pi to the 8th a to the 8th within the square root. And this is going to be 1. We're going to end up with the square root of pi to the 8th a to the 6th over pi to the 8th a to the 8th. So that's 1 over a squared. And then this is going to be 16, but that's going to be over pi to the 4th, a to the 4th. Now 16 over pi to the 4th is less than 1. Pi to the 4th is quite a bit greater. 3 to the 4th would be 81, and pi is a little more than 3, so that's like 1/5 at this point. And we've got an a to the 4th here. Whatever a is, let's go on with one more step of this. I'm going to factor out a 1 over a squared from this term and see what we've got left. Unfortunately, I'm out of paper, so we'll have to continue that on another clip.